Welcome to Transient Stability Analysis using PSSE demonstration video. Now, in the previous video, we created two files. One was the converted file, which was created from SAV file, and the other one was the snapshot file, which was created from the diary file. Both these files are important for transient stability analysis, so that prior to performing transient stability analysis, make sure you have created both of these files. Just to give you a recap, here is my network data file, but this file is in the form of converted file because we have converted this file. So if you see here, the name is coming here smib_32_ converted. So this is my converted file. Then the second thing we have done is we have created the snapshot file, and when I press Control Tab, this is my dynamic data file in which I have added the classical generator model. Now that we have these two files, we will perform the classical transient stability analysis, or the angular. We will check the angular stability in this case. So I go to by pressing the Control Tab, I will go to my SLD just to show you. Here we will check the angular stability of generator number 1. In order to check the angular stability of generator number 1, we are going to initiate fault at bus number 1 or the generator bus, and then trip circuit number 1 between bus 1 to bus 2. By this way, in the pre-fault condition, we will be having 2 circuits, and in the post-fault condition, we will be having only 1 circuit. And we will monitor the angle of generator number 1 and see whether the angle comes back to an other equilibrium position or it just goes out of step. Now to perform this simulation, what we have to do, we have to go to dynamics, we have to go to simulation, and we have to go to perform simulation. Here we have to adjust 3 things. Number 1 is we have to provide the channel output file. This is the file where the output of the channels or all the monitoring quantities we have selected in the snapshot file will be saved. The next thing is we have to provide some simulation options. Simulation options will be number 1, run to. This is my timeline in which I am going to tell PSSE that when a certain event is happening. So I will be changing this timeline when I'll be performing different events. Then print every, write every, and plot every. These options help you to identify how do you want the output of your simulation. If we select print every 0, we will not be getting anything printed on my progress window, and this is exactly what I want, because if I put some value here, say 1 or 3 or 9, because usually we put the values in the form of odd numbers. So if I will put some value here, what will happen that when I will be performing the simulation, all the results of all the quantities will be displayed here, printed here after every number of time steps I have selected. So in order to reduce this burden on the system, what we usually use print every 0. Then similarly write every 9 and plot every 9. So if there is going to be any specific event happening in the system, it will be written after every 9 time steps. Similarly, plot will be saved after every 9 steps. So this is a pretty common values which are used in PSSE. So the last thing is, if you see here, I have 3 options: initialize, close, and run. My run is disabled. This means that although I have a working snapshot file, but it needs to be initialized at time t is equal to 0. So all the state variables need to be initialized at a certain condition, so that after each time step they can change their value. So for this purpose we have to initialize the case, but prior to initializing the case we have to select the channel output file. So I will browse and I can give the name of any file. In case I have selected the file name here to be 3phase_fault, so I am telling this is just for my description that I am having a 3-phase fault at generator bus, and this fault be of 100 millisecond. Then I press open and I will press initialize. Once the system is initialized or the PSSE dynamic model is initialized, you should get initial condition check OK. So if you are getting this option, this means that everything is okay and you can perform transient stability. If you get initial condition suspect here, it means that there is some problem in your dynamic file. So you need to adjust your file in order to make this initial condition okay. So now once we have this, the next step is we are going to perform simulation run to 1 second. Why 1 second? Because this will be my pre-contingency state or pre-fault state. In the pre-fault state, I will run my system for 1 second to see that what was the condition of the system prior to any disturbance in the system. So my first event is run the simulation up to 1 second without any disturbance. So I press run. Once I have run, my simulation has been run. Now the next step is to introduce a fault in the system. So we will be introducing a 3-phase fault. So how we can do that? Now you have to go to disturbance and you have to select bus fault. We select bus fault and we have to select the bus number. In this case, we are going to select bus number 1 because our fault will be initiated at bus number 1. So I press OK. And the next thing is I am selecting a very low impedance. Why? Because I want my voltages to reach to 0 kV. So with this very low value of impedance, what I'm going to get the voltages during the fault equal to 0. So when I press OK, see the generator bus 1 shunt has been added. So basically how this PSSE initiates or create a fault, it just adds a shunt at the location where you are initiating the fault, and this way all the current coming from this source is going to go to the shunt and you are going to see some drop in voltages at this. So this is how this 3-phase fault is initiated. So now I need to run this for 100 millisecond, or 100 millisecond is also equal to 0.1 second. So now my next event in the timeline will be 1 plus 0.1. So this means 1.1. So I am going to run my simulation now up to 1.1 seconds. So I am increasing my timeline. I started from 0 to 1, which was my steady state. Now 1 to 1.1 is this 100 millisecond is the fault duration. So when I click run, my fault has been run. Now after 100 millisecond, fault will be cleared with the help of any relay in the system and my line is going to be tripped. So what I will do, I will go to disturbance and I will go to clear fault. Now my fault was at generator bus 1. So I am going to clear this fault, and in the progress window I am getting the option bus 1 generator shunt is removed. It is deleted. Here it was added. Now after 100 millisecond it is deleted. And the next event is to trip the line. For tripping the line, you will go to again disturbance and trip line, and you are going to select the line. Here in this case, my line is from generator 1 to load bus number 2, circuit number 1. And when I press OK, so it is telling me from bus 1 to bus 2, circuit ID 1. This is exactly what I want. I want in the post fault case, I want only one circuit to be remain in the system. And when I press OK, so now my line circuit 1 between bus number 1 to bus number 2 has been set out of service, and as a post contingency state I am going to run my simulation up to 10 seconds. And when I press run, my simulation is run and everything is complete. Now you can close this. One important point to note here is that once you have performed the simulation, never save the snapshot file, because now this snapshot file contains the state variables at time t is equal to 10, which is not exactly equal to t is equal to 0. So now this is a completely different state. So whenever we want to perform simulation, we want to start from t is equal to 0 or my initial state. So for this reason, whenever you have completed simulation, never save the snapshot file.